This is pre-algebra lesson 4-8, exponents and division. Now in lesson 4-7, we learned that to multiply exponents, we add. So today we're going to look at dividing exponents for a few minutes. Let's take a look at the following problem. 7 to the 8th divided by 7 to the 3rd. Well, 7 to the 8th is the same thing as saying 7 times 7 times 7 times 7 times 7 times 7 times 7, 2, 3, 4, 5, 6, times 7, where the 8 goes, divided by 7 to the 3rd, which is 7 times 7 times 7. Right? If we look at those and we simplify, we can see that one of the 7s on the top can cancel one of the 7s on the bottom. The second 7 on the top can cancel with the second 7 on the bottom. And the third 7 on the top can cancel with the third 7 on the bottom. Okay? So we end up having something that looks like this when you're done. Okay? Now we have how many 7s left? 1, 2, 3, 4, 5. So that becomes 7 to the 5th power. So now notice that 7 to the 8th divided by 7 to the 3rd is 7 to the 5th, which is the same thing as saying 7 to the 8 minus 3. Now when we multiplied exponents, we added them. When we divide exponents, we actually subtract them. So to divide numbers or variables with the same non-zero base, we're going to subtract the exponents. For example, 4 to the 5th divided by 4 to the 2nd becomes 4 to the 5 minus 2, or 4 to the 3rd power. Algebraically, a to the m divided by a to the n becomes a to the m minus n, okay? Where a cannot equal 0 and integers for m and n are positive. So, that leads us to being able to simplify expressions dealing with division. So if I have 4 to the 12th divided by 4 to the 8th, that's the same as saying 4 to the 12 minus 8. And 12 minus 8 is 4, so that's 4 to the 4th power. And 4 to the 4th power is ridiculously hard to do. That would be 4 times 4 times 4 times 4, which is 16 times 16. And 16 times 16 is 256. So 4 to the 12th divided by 4 to the 8th is 256. Number 2, w to the 18th divided by w to the 13th becomes w to the 18 minus 13. So that's w to the 5th power. And since we don't know what w is, we just leave it as w to the 5th power. 10 to the 7th divided by 10 to the 4th is 10 to the 7 minus 4, which would be 10 to the 3rd power, which is a 1 followed by 3 zeros, so it's 1,000. Now, when we have numbers and variables, remember, divide the numbers like we normally would as if it was a regular fraction. So basically, I have 12 divided by 3 times m to the 5th divided by m, which means I have 12 divided by 3 is 4, and then I have m to the 5 minus 1. So I basically have 4m to the 4th. Now, let's say I have 4p to the 3rd cube over 36p cubed. Okay, let's do this one slightly different. 4, I'm going to break that down to prime factorizations. That's going to be 2 times 2. Okay, and then I've got p to the 3rd cube. On the bottom, I'm going to have 36, which is 2 times 2 times 3 times 3, which is 9 times 4, times p times q. So what I'm going to have is, I can look at this to cancel out my numbers. My 2's cancel. So on the top, I'm left with a 1 because there's no other number. So I have 1, p to the 3 minus 1, q to the 1 minus 2, all over 9. Oops, that's q to the 1 minus 1. Still neat. How did I get a 2 out of that? The q to the 1 minus 1, excuse me, go back there for a second. So we have 1p to the 3 minus 1, q to the 1 minus 1 all over 9. So let's simplify that. That would become 1. P to the 3 minus 1 is p squared. Q to the 1 minus 1 becomes q to the 0 power, which is just 1 all over 9. So to simplify this even further, it would just become p squared over 9. I'm getting my q's and my p's confused. P squared over 9. Now you could have simply looked at this and said, oh, I know that 4 goes into 36 9 times the very first step and done it that way too. I just was showing an alternate way of doing the same problem. Now, what happens when you divide powers with the same base and get 0 as an exponent? We briefly looked at that a second ago. 3 to the 4th divided by 3 to the 4th becomes 3 to the 4 minus 4, or 3 to the 0. If I look at it, 3 to the 4th has 4 3's on the top. 1, 2, 3, 4. 4 3's on the bottom. 1, 2, 3, 4. If we cross cancel things out, everything does not become 0. Okay, all these become 1, remember? 1, 1, 1, 1, 1, 1, 1. 1 times 1 times 1 times 1 is 1 on the top, and 1 times 1 times 1 times 1 on the bottom is 1. So that 3 to the 4th divided by 3 to the 4th is 3 to the 0. And 3 to the 4th divided by 3 to the 4th is also 1. So that means anything raised to the 0 power is actually 1. Okay? So 0 as an exponent means anything raised to the 0 power equals 1. Okay? So 3 to the 0 is 1, a to the 0 is 1, and a cannot equal 0. 0 to the 0 power doesn't exist. Okay? It's undefined. Okay, so if I have negative 12 to the 73rd power divided by negative 12 to the 73rd power, that's basically saying negative 12 to the 73 minus 73, which is negative 12 to the 0 power, which is just 1. It doesn't matter if it's negative or positive, it's just 1. If I have 8s to the 20th divided by 32s to the 20th, it means I'm going to take 8 32nds, and I'm going to reduce that, and I'm going to times that by s to the 20th over s to the 20th, which means 8 goes into itself once, and it goes into 32 4 times. So this becomes 1, and this becomes 4. So I have s to the 20 minus 20 all over 4. Anything to the 0 power, remember, is 1. So s to the 20 minus 20 is s to the 0 over 4, which becomes 1 over 4. Number 3 here, 5 squared x to the 6 divided by 5x to the 6. That becomes 5 to the 2 minus 1, x to the 6 minus 6. That becomes 5 to the first, x to the 0 power. Anything to the 0 power is 1. 5 to the first is 5. 5 times 1 equals 5. Okay, let's go a little further here. What happens when you divide powers with the same base and get a negative exponent? Say, for example, we have 3 to the 2nd divided by 3 to the 4th. This is the same thing as saying 3 to the 2 minus 4, which is 3 to the negative 2nd power. Makes sense. Now let's take a look at this, and let's take this and multiply it by prime factor. So it's, in other words, find its prime factorization. So 3 to the 2nd becomes 3 times 3. 3 to the 4th becomes 3 times 3 times 3 times 3. If I was to cancel some of these out, this one cancels with this one down here, this one cancels with this one down here. On the top, I'm left with 1. On the bottom, I'm left with 3 times 3, which is 9, or 3 squared. Notice, 3 to the negative 2nd, 1 over 3 squared. Those are the same thing, just slightly differently written. Okay, which tells us that if we end up with a negative exponent, that's the same thing as saying 1 over that number to a positive exponent. Now this is probably the most confusing thing when we deal with exponents. Whenever you have a negative exponent, to make it a positive exponent, it moves to the denominator and becomes positive. If it's in the numerator and if you want to make it positive, you move it to the denominator. If it's in the denominator and you want to make it positive, you move it to the numerator. So that means if I have 3 to the negative 2nd, that's the same thing as saying 1 over 3 to the 2nd power. A to the negative n becomes 1 over n or 1 over a to the n power. I should say a right there. 1 over a to the n power. Okay, so if I have z to the 4th divided by z to the 15th, if I apply the first rule I learned today, I would do z to the 4 minus 15. which happens to be z to the negative 11th power. But I don't want to leave it as a negative 11th power. So that would end up to be z to, I think it's not z, 1 over, I want to make that 11 become positive, so I have to move it from the numerator to the denominator. It becomes 1 over z to the 11th power. Remember, z to the negative 11 is the same as saying z to the negative 11 over 1. To make it positive, I move it to the denominator, and when I move it to the denominator, the exponent goes from negative to positive. Okay. So there's the answer for this problem. If I have 4 to the 5th divided by 4 to the 7th, that's 4 to the 5 minus 7, which is the same thing as saying 4 to the negative 2nd. Now I need to make that exponent positive, so it becomes 1 over 4 to the positive 2nd power, which is the same thing as saying 1 over 16. Number 3 here, if I have 3y to the 8th over 9y to the 12th, well, 3 goes into itself once, it goes into 9 3 times. So I have 1 y to the 8 minus 12 all over 3. So that becomes y to the negative 4 over 3, but we can't have that negative be in the numerator because we want to have a make all the exponents positive, so we need to move this number down here. So we can't just have a 0 in the numerator. Remember, when you move it down, it becomes 1. Or we have this 1 here, I can still have that 1 here. So 1 stays on the top, and the 3 stays on the bottom, and the y to the 4th moves to the bottom, so it becomes y to the positive 4. So it becomes 1 over 3y to the 4th power. Right, sometimes we like to write without the fraction bar, which means we don't want to have all our exponents positive. And if we have the fraction bar, that means the exponents are all positive. If we want to get rid of the fraction bar, that means we could have negative exponents. So if I look at this first problem here, a squared b to the 3rd divided by a b to the 15th, I will just set up my problem, because it's a division, I'm going to subtract my exponents, a to the 2 minus 1, b to the 3 minus 15. Remember, when a variable does not have a power to it, the power is 1. A to the 2 minus 1 is a to the 1st. B to the 3 minus 15 is b to the negative 12. So we can leave this as a to the 1st, b to the negative 12, or you can just leave it as a, b to the negative 12. You don't have to have the little first on the a. That's writing it without the fraction bar. If I wanted it to be positive, then I would have to move that b to the negative 12 down to the denominator. Number 2 here, I'm going to have b to the 3 minus 9, which becomes b to the negative 6. I'm done at that point in time. I do not want a fraction bar, so I'm not going to make the exponent positive. Number 3, m to the 3rd, n to the 2nd, divided by m to the 6th, n to the 8th. So that becomes m to the 3 minus 6, n to the 2 minus 8. Okay, so in my m category here, I have a negative 3, and in my n, I have a negative 6. So I have m to the negative 3rd, n to the negative 6, and I'm done at that point in time. And my last problem here, x y to the 5th divided by x to the 5th y to the 3rd becomes x to the 1 minus 5, y to the 5 minus 3. So that becomes x to the negative 4th, y to the 2nd. At this point, I'm done. No fraction bars. Everything's simplified as far as it will go, and I am done. Really, exponents in division is not difficult. It's just sometimes you have to remember how to make a negative exponent positive, and that's probably the most difficult thing. We'll keep it fairly simple in pre-algebra, and algebra will get a bit more complicated. But this is lesson 4A, exponents and division.